welcome to our project StudyBuddy. Purpose. The purpose of the goal of our AI flashcards web app, StudyBuddy, is to develop an intelligent interactive web application that helps students study more effectively through personalized flashcards generated using artificial intelligence. By allowing users to input any subject and automatically receiving a custom deck of question and answer style flashcards, our tool leverages natural language processing and adaptive UI features to support deeper learning, retention, and convenience. The system design for our web app consists of a full stack AI powered web tool consisting of a React front end and a Flash back end that work in unison to dynamically generate and display a study flashcards. In our front end, we are using React, which handles user input, which provides a responsive theme adapt. Our React also provides us with a responsive theme adaptive UI. It also displays and navigates flashcards which flip and show the back and forward parts of the flashcards, which have the question and the answers for students to study from. Our backend works with it uses Flask in Python, which receives user requests via a REST API, uses the model of Gemma 3 to generate Q&A based pairs based on the subject, and formats and returns the data as a JSON to the front end, which later gets formatted and shown to the user as flashcards. We integrate AI using natural language prompts, which are crafted dynamically from the prompts given by the user. Gemma 3 handles multiple Q&A flashcards per topic, and the output is structured by the front end with React. Here's a summary of our technology stack. Our front end uses React, JavaScript, HTML, and CSS. Our back end uses Flask with Python. The main model we're using for AI, the only model we're using for AI, is Gemma 3, and we styled our UI with CSS. Our backend logic, we already talked about this. Built to Flask, receives user input from React front end, uses Gemma 3 to generate flashcards, parses text response into JSON objects, sends the structured data back to the React display, includes error handling and validation. These are our key features for our web app. It gives AI generated cards based on any subject which is given to them through a prompt. It can give a custom number of cards between 1 and 20. It lets you flip through the cards, like the front and back, to see the answer and the question and the answer. It can be exported as a text file. There's a light and dark mode toggle. We also provide error handling and loading feedback, and a responsive and modern UI. This is how the input screen would look like. It lets you input whatever subject as a prompt, the number of cards, and to generate it. It also, this is the flashcard view, which shows the flashcard under the prompt view. And if you click the flashcard, it lets you flip through them and move from the previous to the next flashcard. These were the main challenges of our project. API limits. OpenAI and Gemini, which were the two models that we thought of at first, had token limitations or required paid subscriptions, which restricted our ability to scale and test freely. Model integration. Switching to Gemma 3 required local model hosting, which introduced a new challenge like model size, resource usage, and dependency management. Data parsing. AI output was plain text, not structured. We built a custom logic to parse questions and answers from the new string, front-end and back-end sig. Coordinating the data flow, handling errors, and managing asyncs between the React and Flask gave us a lot of problems a lot of times, since a lot of times, even when we try to set up the app, there was a lot of problems with the front end and the back end not being synchronized, and that bringing a lot of problems. These are some of the solutions that we came up with these problems. We switched to Gemma 3 to avoid the problems with Gemini and OpenAI. We avoided token limits and costs by using an open source LLM hosted locally. We also used text cleanup. We developed a parsing algorithms in Flask to extract flashcards reliably from free text AI output. API endpoints. We built a simple REST API to ensure reliable communication between the backend and the front end. In the front end, we also added user-friendly features like loading indicators, error messages, and dark mode for a better UX. Improvements. To improve the app, we could at some point also add things like accounts and save decks, so that you can have like several decks that you can choose from and save them, so in case you want to go back to them later in the future instead of having to export them. Maybe a space repetition algorithm to help students study subjects over a long period of time. There could also be flashcard editing or rating, so that you could send some kind of feedback to the AI on the quality of the cards. We could also create some kind of mobile app version so that it's more accessible to students, as many times a lot of people don't know or don't prefer to use computers. Or a speech-to-text input for the prompts, or an image-based OCR so that we could maybe upload nodes, and from there it could create flashcards based on that. Conclusion. Our AI flashcards web application StudyBuddy successfully combined modern web development and AI technology to create a smart, customizable study tool. By overcoming API limitations and integrating an open source LLM, we built a full stack application that demonstrates the potential of AI in education. The project strengthened our skills in front-end development, back-end design, AI integration, and problem solving under realistic restraints.